Good evening, everyone. Welcome. And welcome Aki, Steffi, you, yeah. Sorry that it's quite such a late start. Yeah. Sorting myself out, took longer than I planned. Welcome, Nikolai. It doesn't help that it is melty hot still. But, anyway. So, I think first I'm going to do a quick catch up as to where I've got to with, dragonBoot and other things. As you can see, there's code here that you don't recognize. Oh no, I'm going to skip this song, because... So, between streams, I've spent a bit of time figuring some details out that were quite hard to get figured out. And doing things like finishing getting the keyboard working on the stack that we've been working on. This horror of horrors in some respects, but actually it's rather nice. And figuring out how rebooting on this ARM chip works, because it's weird. And figuring out that the easiest way to do a reboot is not to do a reboot, but rather to reload certain system registers and switch execution over to a new region of memory. Just need to change which console I'm looking at. Here we go. So, in all of this, we now have this many warnings. It's really not very many. And a solid base, I think, to start writing DFU stuff on. So, this is the register that I could have used to do a reboot. And I can't, actually, for a few reasons. I can use it to get into the bootloader, but not the bootloader into the firmware. Now, there are two reasons for this. The first is that the kind of reset I want to do is this VEC reset here, which if we were to look at the ARM technical reference manual for the Cortex-M4, does exactly what I want. Perfectly. Resets the core, does not reset any on-chip peripherals. Da-ba-da-ba-da. Great. On the Tiva C, because of how they implemented debug, that's not how it works. Writing to VEC reset would be an error. At least, as far as I can discern. I'm just not going to poke it, because I worked out how to do it without that. Now, sysresrec there, god that's a mouthful, which is the system reset request, bit, does work to reboot the whole thing, which is how we can go from the firmware back into the bootloader. Great, especially as I can detect this. Hey Amy, welcome. So, it is running a giant stack on the top of that, so to be fair, my fault? Kind of. Please do open that PDF, I really think, there we go. It's nice that we don't have to think too much about that though, right? Of course, this is the one that has nothing actually turned into proper links. This PDF is a real pain to work with. So, as of the end of last stream, I figured out how to do part of detach, but we need to actually revisit this because the current way of doing things does not have a way to hook the stack with, hey, could you please now deal with this function I need you to call having finished sending a packet, for example. Which is bad. Especially as this needs to happen after we send the reply to say, yep, we got your request, doing it now. So in SPIFlashProgrammer itself, I actually started to have a play with how this might work. I think it was in here. It should be in here. Oh, no, it was in, yeah, okay. Getting myself confused as to which project has what on it right now. It was in here. I started to implement detach and figure out how it might work. So we have this function, detach, that takes us off the bus, marks the local state as we've done the detach part, now reboot the processor. And this function, as the comment so helpfully says, must be defined by the firmware that's using this, whatever that firmware is or does. Which, if I look again at SPIFlashProgrammer itself, I remember where I put the definition. Oh, that's right, I didn't yet use it in here. Well, what we'd end up doing is writing a small thing in the USB DFU namespace that issues that system request to reboot the processor, and mark that function no return, because of course it reboots the processor, so it will never return. Now, for dragonBoot itself, this is a bit more complicated because we are working after we've entered DFU mode. Probably. I think what I want to do is I want to make the reboot stuff actually trigger the same reboot mechanism so that we can do this reset cause was software must enter bootloader becomes true. The reason for doing this is so that we can change how the DFU stack initializes depending on this state information that we can glean from how the processor got to where it is. So what I think I want to do, because how does this work again? Yeah, we register the handler, that's what it is. We've got config, and we've got state inside a config. Now config is global, I think. Oh, no it is not. How to do that then? I could either make this visible in the header, or I can add a function that allows you to play with the state of it in a very predefined way. I think I'm going to do the latter. Welcome, Iris. Welcome, welcome. Yes, because what we can do, if I've got that as a function... You're adorable. I think Streamlabs might now be on a timeout. Thanks, Streamlabs. No, you don't need to be a mod. Oh, no, yes, it does need to be a mod. Mumble, mumble, grumble. Try again now. So, it's because of the speed at which it was answering. It gets rate limited, same as the rest of you otherwise. That's also the reason why it had a delay between you typing yeah and it saying, hey. No, it doesn't use IRC as far as I know. I think it's using the API for for Twitch. It does have an API. So if we do this... Curious. So if we do this, we have the ability to get into the right state when the software hosting us says, yeah, we're in the right state. Now, the other problem I've got here is that currently I've introduced this idea of callbacks on the controllers, on the endpoint controllers. Now, the reason I have not committed this yet is I'm not very happy as to how I've defined it. So if we look at, gosh, which header will this even be in? You don't need that. You don't need that. You don't need that. Ah, here it is. Callback T. So currently this just takes a function that takes no parameters and returns nothing. And I'm wondering if I need to change that any, or if that's okay. In addition to that, I need to somehow re-null the callback back out after it's been called. And put the call for it into the stack somewhere. Which, where will that be? That will be in core. Yeah, it's the per device core, so this is this one. We have how will that work? Because the way that DFU works is that this is all done on the control endpoint. Which is done through the device driver, not through core. This. Because technically, what's happening is this is getting called every time we need to do something. Oh, also, I've just noticed something. If response not equals, response T unhandled. Oh, yeah. Break. Because we actually do need to exit that early if we get an answer. This was the reason why I didn't commit it yet. That's right. So what I'm thinking is, instead of the status endpoint stuff getting this extra member, and therefore increasing in size by quite a large amount, it makes a little more sense, I think, for a handler to register on the device driver that it wants calling back at the completion of a setup packet being handled. So when this fires, we have a valid response. We do a zero length packet answer, which is handled here. Welcome back. Yeah, I want to move this into the device driver. And this is going to be set up fallback. And then in complete setup packet, if setup callback, and then set it back to null. Correction. Rather than putting this here, we should put it here. Because then we can maneuver this code into its own function that gets registered this way too. Which makes the design of this a little cleaner. And stops a spurious extra callback into the interrupt handler after a reboot. Hey Freya, welcome, welcome. I'm just having a moment here trying to figure out how to structure this particular bit of code. So this is handle standard request, set address. Yeah, in here we'd go USB status addressing, setup callback equals set address, let's say, or perhaps just address, which we then define here. Yep, that's understandable. Glad to hear you've got food. Or had food, rather. Yeah, so if we've got a function called address, we then set that as the callback. And then that will get called back here. That makes me feel okay about how this will work. We then change this to also use setup callback. Now we have the same thing will happen here. And that will mean that detach fires on the right half of the bus cycle. Which is once the reply has been sent. That solves a massive headache of a problem I had, which was making sure that the reply from detach here happened before we detach from the bus. Because we need to say, we're detaching now, before we do it. So, okay. Let's check that that built. I'm gonna have to quickly clear out that, because... Clean up. Meson, build that. Meson configure drivers, DFU, run the build. Great, it built. That's good. No, before I do that add, we need to do device, set a callback, that, not that, not that, not that. This is going to take a little bit of doing, because I actually have a couple of different sets of changes that I need to queue, as you are seeing. So, having done that, let's do this bit. So, one of the changes I realized I needed to make last night when I was trying to fix something else up to do with the keyboard, that you've been seeing all over this code here, is that there were a lot of checks that were missing or slightly wrong, to do with making sure that the right endpoint directions were set for a given packet, etc. Or that's Pat's Amy, sorry. So, among other things, if the direction's wrong, we want to stall, not do an unhandled, because it's just the wrong direction. Stood tie is a way for you to take several variables, temporarily make a reference tuple from them, and then assign another tuple to that, so that the values are copied. So what it does in effect, here, is it takes response, data, size, and memory type, makes a temporary tuple of them that is of their references, and then takes the tuple that handle standard request t spits out, and takes the data from that other tuple, the handle standard request tuple, and writes it to each of those things in place for place inside the tuple. So the result of stood tie here, if I can get my IDE to play ball, which I can't. Excuse me a second while I just do a reload required. That will reinit IntelliSense, which is what I need in this case. Let me also just quickly change this lot over so that we're on the right page with the IDE as to what's what. Because I did just change the build over to be Tiva C based. Change the compiler. This needs to become none EABI, and that becomes Linux GCC There we go. So as you can see, it's making a tuple of a response ref, a const void star ref, a uint16t ref, and a memory t ref, which it can then use in the tuple assignment operator to be able to take the other tuple, which is a response t, a void star, a const void star rather, a uint16, and a memory t, no refs, and copy those values into the variables that are being referenced by this tuple. Does that make sense? I hope that makes some sense. Fixed up a pile of missing checks for state validity in the set up packet handlers. I've got to come back to that. So we then have added a function for configuring where we are in DFU between reboots. Implemented the DFU detach request. So if we push that upstream and we pull that into dragonBoot, undefined reference to DFU reboot, we expect that, because I have not yet implemented that. I'm going to say this is a platform item. Lewd. And a little rude, but mostly lewd. That's enough to make the function defined, but we actually should make that do something. I'm gonna make it loop forever. If this fails, that makes it easier to debug. And then we want to do... This is on the system control unit, the SCB. And there's the 8-point register. We want to set it equal to vals SCB 8-point vector key, or rather 8-point key, vals SCB, and I've now got to go and edit Dragon TI because we're missing some stuff there. These constants don't yet exist. So this will be a point system reset request, because I am not afraid to actually make these readable. And then, what order did these end up in? Yeah, so system control is above SCB here. And then if we then define const express static constituent 32t a point key and a point system reset request. Don't worry, I'll actually give those values in just a moment. So this field is used to guard against accidental writes to this register. This must be written to this field in order to change the bits. This same thing, but byte swapped, is red whenever you try and read the register. That stops you from doing all equals tricks, by the way. So I think, yeah, that's the upper bytes of the register. And the lower 2 bytes, the ones with all the interesting bits in. This is non-swappable endianness, which is why this is read-only 0. Some ARM processors, by the way, do allow, on the older processors, do allow you to switch endianness. None of the Cortex ones do. Unless some vendor has played in some very fun ways that are not officially sanctioned. You could. That would be the only thing you'd be doing, but you could. No, you don't, because you can't do, unless you preload 2 registers and stop the compiler ever touching them, ever, your first 2 instructions in your instruction stream will have to be loads, to load the constants required to write this register. Then you'll have to do a register store, an STR, I think it is. It's LDR, STR? Yeah, STR. To store that loaded value into this register over memory. But before you can do that, you've also got to have loaded 2 more registers with, or 1 more register with the address of this register. CPU registers versus memory. Yeah, that would not be very fun. I guess you do, once you've got it all set up, I guess you do get to put another thing in between each instruction that writes this register, but gosh, your code's gonna be awful to work with because of those writes that you're always doing, which can wipe out status information. Anyway, we don't want to touch the priority group stuff. We don't want to touch those. Those need to be written as 0. Cool. And that is bit 2, so hex 4. Pats. Sleep well then, Freya. So, okay, that's not too bad. We added 4 bytes, that will be that pointer, to RAM, and we added 236 bytes to the program. That's pretty good, actually. The question I now have, I guess, is, does this even work? Descriptor-wise, we have the right descriptors, so that's fine. And if we enumerate as the bootloader, then we know that we've correctly entered bootloader mode. Don't think, yeah, I didn't add a program target, so what I need to do is pull the program target from SPIFlashProgrammer here, which is this fun bit of GDB script. should be that, I think. Ah, would help if I plugged in the cable for Blackmagic Probe. Okay, that's got it plugged in. Try that again. Ooh, fun. I managed to typo right there. So in theory... Hey, that was easy. This has never been run before. I've never run the code for the bootloader before. But we've just got a disconnect, full speed device, new USB device. I need to change that. Because the correct vid PID pair is actually going to be bad B. So let's do that. What else? Dragon USB DFU bootloader, bad alloc heavy industries. That all looks great. Let us read out the descriptors. And we see device descriptor, bootloader DFU configuration, all looks good. We're bus powered, max power, interface descriptor, application DFU, interface, interesting, 4 error. That needs fixing. That will be something in here, I think. $33 bytes selected. Yeah, that's all looking normal and fine. Well, I'll have to come back to that interface, string descriptor not working. We then have the DFU interface, length 9, attributes, will detach, manifestation intolerant. That all looks fine.
You are now entering the arena. Good luck.
Well, that's amazing. I need to actually attach the debugger at this point, I think, because I need to see some internal state. It helps if I actually tell it where the firmware is before we then go and do attach. Ah, right, before I run this, actually, I need to do the thing where I tell DFU core whether or not it needs to do anything special. Which... reset causes reset software, then we've detached already. I love that you can just run commands inside a GDB back on your shell. Exclamation mark is a way to quickly escape out of GDB and run something on your local machine. So if I set a breakpoint, yes, in theory I could. Why is that not found? USB DFU detached. I definitely have that function. Yeah, Splat Zish gives you a shell again. Cool. Which is very useful in this case because I need to run a more complicated command to peer inside that binary. Oh, I didn't provide a disassembly target. Oh, interesting. Look, it's GDB, okay? The easiest way I'm going to be able to do this is, again, copying from SPIFlashProgrammer. There we go. Well, kind of. There we go, that's what I was looking for. So... handle DFU request, various initialization bits, read discard, IRQ reset, detach, address, read endpoint, write endpoint, which is horrifically long, IRQ USB, memcopy, memset, and the descriptors. Ah, this is a release build, isn't it? Yep. Let's go for a debug optimized build. Interesting that that's smaller. And that was built with... I actually can't tell what optimization level that was. -02. It's still a bit high on the optimization level. Those aren't instructions. Apparently those need to be double slash comments. Okay. Significantly bigger. That's what I was expecting. Okay. Can I now get a breakpoint where I was trying to get a breakpoint before, which is in USB DFU detached? Oops. Yes, I can. So the actual line I want is line 24. I forgot this was a really big structure. Reset cores, hex 1, 2. What does hex 1, 2 mean? That's all of the system blocks, but that's not the system control registers. Ah, there it is. It's going in the wrong direction anyway. Oh, interesting. So... just trying to think how I deal with the reset core stuff here, because we need to clean up. And I think what I'm going to do is, before we do the attach, we do syscontrol reset cores is 0. We reset the reset cores register. And likewise, just prior to rebooting to firmware, Okay, that's now just purely because of a software reset because of the debugger. Ah, how do I even detect if I'm rebooting because the debugger made me reboot? That's... That's almost like there isn't really a way to know if the reset cause is because software wrote the a point register and set the system request reset request bit, or whether it's the debugger that did that. What on earth to do this then? In the system properties, it's read-only. There's various run mode registers, but those should all be being reset by a reboot. The only thing I can think to do here is like use some byte-in memory that we've reserved by hand somewhere that is not reset between restarts, but which has a known value when the system comes up, and a known different value when a reboot initiated by either our reboot routine or the firmware reboot routine triggers. And that's actually hell to do. That's why I was trying to depend on the reset cause. These are the bus settings. This is KLL state information. Our favorite register. I guess what we'll have to do then is we'll have to make it so that it's not an error for the DFU driver to be re-entered for detach, trigger a new detach, even though it thinks it's DFU idle. But this has an impact that this will always mean, what, with a debugger attached, we will always enter bootloader mode. Because it will always boot the system using a reset like that. And the only way I can think to get around that is to check if reset causes reset software and syscontrol reset cause vals system control reset power on reset is not set. So this is if we are reset by software, but we are also not reset by power on reset. Clear power on reset if no. Ah! Okay, now that's a point, actually. What we can do... if our reset cause was... oh, we think we've got software reset, but we've also got power on reset set. Then clear the software reset bit, else return true, and then that will from then on know that we actually got power on reset despite the debugger and allow this code to do the right thing. My brain's melting. God, the tricks you sometimes have to do. Yeah, so our reset cause is now just software reset because we did do a bootloader forced reset the system. Yeah. So if I look at USB, there we go. Yeah, we're in the bootloader again. God, that is really horrific. So having implemented detach and figured out how on earth to recover from what is effectively a state of insanity, we then have the download and upload transactions that we need to handle, which is actually the main reason we have any warnings left on this project at all. It's also the difficult part. DFU init, defined but not used. Oh, this is the wrong file. I'm looking at that defined but not used warning, because that's actually a problem. Or init handlers. Oh, it is cool. Because we don't have any endpoints for this, then stud array is 0 length. Init handlers won't be doing anything. In that case, init gets called in register handlers so that the DFU driver is initialized. Yeah. So the way that download works, how does download work? Device specifies the maximum number of bytes per transfer via the WTransfer size field. So we answer the response. Oh, how on earth does that work? Oh, this is based on what we say in the descriptors earlier, so this will have data following for us to read. Right, okay. So if we define a not static, well, no, it will be static. Stud array, uint ep data. Oops. I don't recall what the counter is actually called. It's in constants. This is what I'm looking for. How's everyone doing, by the way? Hopefully you're all doing well. Good. I'm glad to hear that, Steffi. I could have just a listing of all of the... There's the class-specific requests, but I need to know what directionality they have. Ah, here we go. Because I need to do some further checking, like I've just done over on the other... The ones in here. This checking, this is what I'm thinking of. So for things that are data none, we expect them to be in mode. I think that's right. No, those are out mode. Really? Oh no, this is the... Right, this is the opposite way around. Yeah, okay. Just making my head hurt even more, these checks are the opposite way around to the bits here in the table. Which probably needs documenting. So we've got abort here, should be an out mode transaction, so it must not be an in mode transaction. Get state should be an in mode transaction. Clear status should be out mode. Get status should be in mode. And detach should be out mode. Okay. Download is as well a in mode an out mode transaction, because it's coming to us. So this will be return handled download. Which for now, let us just make that return zero length packet. We just acknowledge that we got the download request, but don't do anything with the packet that it puts in the endpoint buffer, because I'll deal with that in a moment. Let's see. Cool. So this implemented proper checking of the request direction flags in USB DFU and all DFU request. Added a stub for handling the DFU download request. Added a missing pull to USB DFU init. So the way I want to handle this is actually quite similar to the way that SPIFlashProgrammer's Flash Proto works, where we, inside the handler, perform additional read requests so that we can say, hey, we've got some more stuff to do here on the endpoint, etc., make it do stuff. Like this. Because there's no reason we can't. The only difference here is that this is on endpoint 0. The request buffer is not a request buffer, it's just buffer and buffer.size. Need access to USB core things here. So internally I'm gonna have to keep a where am I in the firmware as a uint16t to allow it to wrap. So we want or packet dot value not equals block position. So if we get a block out of sequence we want to stall, it should always start at the 0th block, I would imagine. So we have a offset. This is actually going to be more than a uint32t. This is going to need to be a uint32t. We'll deal with chips bigger than 4 gigs at a later date. The offset will need to start based on the zones. Also, we're going to need to do a setup callback. We're not currently using the device namespace, that's why that doesn't work. Is download step done, because we need to do this idealized sync state thing. So we've gone through detach. I'm trying to work out how and when and all of that we actually need to start doing chip specific like erase commands, for example, so that we actually can erase the flash, rewrite it with new data, etc. Which of course for the device version of this is going to be just stubs, because we don't actually need to implement anything. We go through reset, we go back into the bootloader. The bootloader deals with all of this. For the bootloader, those need to not be stubs, but I need to somehow figure out how to do an erase with a given address, and then do a write with given data for a given address. See, the other thing I'm thinking here is, because we're allowed to make the amount of data to transfer much bigger than the maximum size of a USB request, we could technically go and say to the system, hey, we actually want EP buffer size multiplied by 4 bytes in a given transfer, please. Which would make everything a lot more efficient. But we also then have to change our descriptors here to change this maximum transfer size. Which is whatever, that's easily done, but the spec does not make this very clear. I'm also trying to work out still how Sylvian's driver actually does its business. I think... Ah, there we go. It does its business in the start of frame handler, which is the reason I've had this deal with starter frame stuff smashed all over the place. I'm just trying to work out in my head now, how do I add like a starter frame handler? Now, how would that work? It's a USB core thing. And I think it'd probably be per interface. Nothing to be sorry about there, Aki. So we've got the interface and the soft handler T handler. Now I have to remember how to deal with starter frame on this chip. That's going to be fun. So if interface is greater than or equal to interfaces count, return, oops. Otherwise do a soft handlers interface is handler. And we set to null pointer if we want to unregister. And these are going to need to be in the internal header. Okay. If status and vals USB interrupt status soft for const auto ref handler in soft handlers if handler which what that will do is for each handler, once we hit the starter frame interrupt request, it will trigger whatever handlers are registered. Interface count using USB constants interface count. Which what we can then do with that is here, register soft handler on our given interface and this will be a function we'll call tick. Which we'll implement down here. This will be the bit that does the actual dealing with data that's been requested for download, etc. And we'll have to just maintain some internal invariants that make sure that we don't accidentally step on stuff. So in our DFU types header, let us do enum class flash opti none erase right. Yeah, because what we can do for erase is we can do a device-specific page erase. So, for example, on the C, if we look at the flash control stuff, where is that? It's one of these registers, if I recall correctly. I did find it at one point. It was in a weird space, or weird spot rather, in the datasheet. Ah, here we go. Internal memory. So... there should be an explanation in here as to how flash erase write works. Right, page arrays, mass arrays. Yes, okay, so this in this case is going to be page arrays write based, same as the DFU bootloader stuff in Nitro FPGA that Sylvian wrote, which I'm using as my basis of an idea as how the hell to implement DFU. Because the spec is not complete enough. The way it works on the Atmel chip will be that we do a page arrays on the buffer, like we were going to do with the profile data stuff. We then load that page up with data through multiple iterations of the download call, or however we make that work. And then at the end, we then do a fused erase write cycle on the underlying page, which is going to be fun to do. So looks like the alt mode sets the zone. Ah, alt mode set the zone. Okay. Now I know what the zones were for and why they're important. So if we make a global of this up here, this is static substrate, or not const rather, static substrate span t int pointer zones. We'll rename the parameter to flash zones. I need to change how that's working, because that actually won't work for what we're doing. How is a DFU zone defined in Sylvian's code? Start, end, and flags. Okay. Oh, I know why I started writing this as a substrate span. Right. So this is actually going to be a uint footer t start and a uint footer t end. I'll deal with flags at a later time if we need them. And then we want to take a span of zone t. That's really awkward that device actually doesn't handle, or core rather, doesn't handle when you want to do stuff on an interface because it's too endpoint centric, which is actually a bug. Ugh. So for init here we take currently interface. I think handler t was intending it to be an endpoint, but it doesn't matter. We then also have dinit and no handler for when we are being called back for a given interface because we're not doing endpoint related stuff. No need for a null pointer, just unregister the soft handler. So what we can then do here is flash state t has a zone, a flash opt operation, just op actually, because this is going to be flash state.op anyway, so actually, it's not going to be a zone at that point. This will need to be uint footer t begin addr uint footer t and addr. Actually, this is, I see why Sylveon's done that. There's a read address, there's a write address, and then there's a programming, an arrays address. And we need some way to be able to register that as a interface handler. Something along those lines, but of course that will not currently build because we do not have that function. Let's see. That will mean that that's only called... Yeah, this is much better. This will only be called when the interface is switched onto by the computer driving this. That means we then get flash state variable. Block position, did I make that public in any way? Nope. Should be static. Actually, all of these should be static. So we want to say that we're in the idle operation state, and then const auto ref zone is zones packet. How to determine the alt mode that we've been asked to go into. This is a really wild goose chase of a spec. This is quite frustrating to me. Attach. I think I want the set configuration request and see how that works again. Or was it, no, it was set interface. Here we are. Oh. So the way that this request works is that this takes an alt setting and an interface on which to act on. This is actually the information that the that we need to act on to correctly deal with setting up for a DFU request. And I think internally at the moment this is handled. Here with this alternate modes. So we've got interface count, length. Okay. So how does this relate to detach? So you've got the reconfiguration phase. Transfer phase then starts. It just says after re-enumeration happens, but it does not say if we should expect set interface. I would have expected that yes, we do need set interface. So we gotta detach a reset. But then it doesn't mention how to get to down. Frustrated dragon sounds. I think what I'm going to assume is that before a download happens, we get called through set interface, which gets acknowledged. But of course... Okay, yeah, I know what I'm going to do. This needs to also activate callbacks. That's how we deal with this. So, instead of having a DFU handler, all of this... what member was that of packet? This was the value member. So if value is greater than or equal to zones dot size, return. Otherwise we do the actual thing. And index is the interface. Gosh, just making mincemeat of my own code. Okay. Should check how we are on the build. Ah, substrate's span has an error in it. Curious. Take care then, Iris. Sorry that my madness has basically been overtaking the stream. I haven't been doing very much explaining as much as I've been just trying to make things work. But right now, I'm going to switch off of using substrate's span to using stud span, because I should have access to that. At least for now. I forgot about that. This is not defined until C++20, and I'm writing in C++17. That's why I was using substrate span. Bollocks. I have to go and fix substrate span then. And yes, that was a very British thing for me to say. Oh... This is an alt mode handler, actually. That'll help explain what that's doing. And this is just a callback T. But that's now gone away. This is going to be an array of callback T interface count. Alt mode handlers. Here it is. Just realized I've just oversimplified that because this is per config per interface. Joy. That now broke this again because this needs to do per config per interface. Yeah. Const auto handler in alt mode handlers active config -1 if handler Why does that think those are starter frame handlers? Oh, because I copy-pasted that wrong. Oh no. That's... USB device callback T. Okay, apparently the alt mode handler's IntelliSense is the wrong thing. It should be right. Ah, just smack the wrong keys on the keyboard. Go me. Okay, so now it's just the stud span stuff that's preventing this from building. Let's do some version control. Because I've changed a lot of files in a lot of ways. So let's do starter frame handling. So there's the soft handlers. Implemented. Oh, actually, I've just managed to miss a header. Include USB internal core. That. Implemented. Start of frame. Pullback. Handler registration. And then we've made use of the soft handlers in the Kiva C USB core handle IRQ. We've then done alt mode handlers in device. So we need to do the interface part of these changes. I changed a lot in that round. So we've got the zones stuff, which we'll need to keep. And then the register handlers stuff. I need to be able to access those namespaces. I do not need the buffer yet, because we've just made some changes to config and put in a global for the zones. We do not need to do the tick stuff yet. We do not need to do a handle set interface or DNIT yet. We'll come back to that. We'll come back to that. Yeah. Yes, cutie. Yes it is, Aston. Hi. I am doing horrible, horrible things with DFU, so welcome. Have I got any thoughts? I have lie, flop, and yeah, I guess. I'll give it a look in just a moment. So this is added proper handling for Ooh. You're implementing fucking structure in C++, aren't you? I approve. I'll show everyone that in just a second and why it works and how it works. Because that's cool. I like it. Added proper handling for the zones parameter having fixed. It's defined to USB DFU register handlers. So we then have that. Ooh. I'm sure you/we will figure something out. Yeah, because I included the soft handling there, so git commit. Oh, before I commit that, actually I need to make sure I've included stuff in here that I need. Oh, no, that's it. Okay. Added stubs for various. Ooh, excellent, excellent. Shall I keep that completely secret? Or do you mind any spoilers being shown about what we've been working on? I won't do anything until you say yes or no, by the way. Because that would be mean. Added stubs for various components of the DFU mechanism required. So okay, no worries. I will hold off then. Looks good though. So this is what Aki's been working on. This is where you take a pile of bytes. Okay, thank you. For example, something you've read off the wire, you have a structure that's defined in some fantastic way, like in Python's structure mechanism, and then you can then do from bytes and from container, which makes takes that sea of bytes and actually interprets it in a useful way that means that you can then access like the second fields uint32 number, you don't care that it's big endian because that's for the structure itself to know about. You just want to know what's in the thing so you can do stuff with it, right? That's what this is for. And that's just cool. This is very structure, sorry, from Python. Good. This is the Sylveon source. Construct, sorry, yes. I keep thinking it's structure, no, it's construct. So this is the Sylveon source I've been using as my basis. Now you can see why I realized that, oh right, yeah, he's done this for a really good reason. That there are actually things that we need that for, and I've just realized that this actually should probably return a boolean so we can return false and return true. I like that. That's actually quite a cute name, Nyake. Not to be confused with Nyaki when I nya her name. So most of the changes I've got left to commit are partially complete chunks of code. So let us finish writing. I hate how much of a rabbit hole this is. We've had to, in order to implement download here, we've then had to implement tick, and then to make use of that, we've then had to implement set interface. I will unwind the stack shortly. Because my head hurts as well. So we've grabbed out the alt setting, that's value, and we've grabbed out the index, the interface. So, having got the zone, flash state, read address is zone start. Likewise, the erase address and the write address all start there. We also want to do a I think I now know why that's not being checked in any way in the other firmware, because it's actually impossible to track that between various things. Anyway, we then also have flash state, end address, zone end. Welcome, Obliterous. We register our starter frame handler. This is complaining because index is 16-bit. Set interface. What was the part of set interface's index that we were using here? The whole thing, apparently. Ah, okay. I can't just iterate through all the alt modes. Because this is done on an interface specifically. Yeah, otherwise this would do the wrong thing. Which would then also allow us to then deal with, like, okay, did this fail or succeed? If it succeeds, then we do the ZLP, otherwise we do a... Which is probably if handler and not handler brackets break. That's probably how I deal with that. What? What's the matter, dear? Oh, really? Can you use string views in a const-eval context? I thought you could do that at least. Or it might have been strings in a const-eval context as well, actually. Yeah, I don't know how to square that one, sorry. Which standard was const-eval added in then? Oh, 20. Yeah. If... I'm just trying to work out in my head right now how the byte order of index 2 works. This will be little endian, so... I want byte 0 of the interface. That's what I'm looking for here. Which Oh, okay. Byte order's already set by this readout. I think what I'm going to do is I'm just going to fix the signature of the functions in question so that they stop warning. This is register alt. No, it wasn't register alt mode handler. It was the starter frame handlers stuff. Yeah, this needs a uint16t interface so that we can use packet index correctly. And then the alt mode handlers here, using alt mode handler t is bool pointer taking no arguments. Allowing this to return bool, false, true. I wish that scrolling worked properly. There we go. Soft handler, we've just changed this to take a uint16t in both instances. And I'm going to make this so that this checks the result of handler and breaks if handler is true, i.e. not null, and the call to the handler results in a in a false return, in a fail return. So we change alt mode handlers and alt mode handlers. Oops, scrolled straight past the thing I was just working on. There we go. Now in theory, this should work so that we get... actually this is going to be return... stall response in the case of a bad request. Yeah, that logic's fine now. Oh, the number of warnings we've got is reducing quite nicely. Yeah. Hi, Angela. Welcome, welcome. To Rachel Goes Completely Insane Hour, apparently. Oh. Welcome, Jazik. Thank you for the follow and welcome to the stream. So having fixed the soft handlers there, we need to do the same thing. Oh, shush, Obliterus. Need to do the same thing in core. Fixed the type of the interface parameter of register and unregister soft handler in USB core. Let's inhibit my shell from interpreting that. I just spotted another mistake actually in those functions. Oh. Yes, it is a funny old world. I might remember if I knew what your real name was versus your handle. Though, you don't have to disclose that to me publicly if you do not wish. You can just send me a whisper, if you prefer. Especially as you'd probably have to tell me your dead name. Which, yeah, funny old world. Understandable. I completely get that. Oh gosh, now I have to remember back to who had what handles at uni and... But hey, welcome. More the merrier. So having fixed the constant correctness there... Right, let's continue doing the source control side of things. So we've introduced a proper type for the alt mode stuff. We fixed the way that it's used. Fixed the register USB device register alt mode handler call and handler usage. We will need those next. Then there's going to need to be yeah, that actually all looks fine. We do not want those bits. Implemented the bones of, or rather the details of USB DFU handle set interface. Fixed some constant correctness in USB core. God, that's a mouthful and a half, isn't it? Okay, we are down to mostly just DFU driver changes, which we need to finish writing the DFU driver to make those actually go upstream. So in tick here, we need to actually deal with the motions of doing an array cycle, etc. What? I'm also presently melting in my room. It's great. It's only 15 Celsius outside, but it's a might tad warmer inside, and the humidity level is insane. Other... I want to put this in dark mode before I put it on screen. Settings... there it is. Oh, man, much better. So this is what Aki's just sent over. Line 16. Well, this error here... Is there any reason why you're using an anonymous namespace for that? Oh, I see. Oh, and I see that the length is coming from... Oh. That's smart, though. Because this is going to match this constructor. That's how you're getting the length information. To automatically make it into a... Oh, you're smart. Oh, well, at least you understand how it works. I've just taken a good few seconds to figure out what on earth it could even possibly be doing. Yeah. So, for tick, we've got, if flash state is operation is flash op none, do nothing. Otherwise, if we are in flash state op erase, I'm gonna need to know how many bytes to erase for. Which is going to need to be the device's page size. Sure, we'll say stud size t there just for good measure. I'll actually put those all as studs, because they're all in the stud namespace, so why not? So if flash state erase address is greater than or equal to flash state write address plus flash state length or actually this would be byte count, we'll call that, not length. Makes it a little bit more obvious what I'm doing. And if this is true, then the operation needs to become a write operation. Otherwise... Otherwise, we need to actually do some kind of erase cycle, which is going to need to be another thing that these must be defined by the user firmware. Called by the DFU driver to reboot the device correctly, called by the DFU driver to erase flash space ready for writing data, called by the DFU driver to perform the flash write. So this is going to be extern void erase. The address is going to be a stored uinput t, and then we need a length, which why not make it a stood size t? Because if we make this so that the buffer, instead of being defined in EP buffer size, if we make this defined in flash page size, and we insist on flash page size for the download side of things, then we can just do whole flash page at a time IO here, which would be perfect. Actually, that's a point. At the moment... we're depending on this. We actually need a thing here. Const... extern const... size t flash page size, and if we define buffer in terms of that, the erase in terms of that, in case the erase is of smaller, or rather the buffer coming in is of smaller size than the actual page erase size. Yeah. If flash state operation is now flash opti right, and this is just general state actually. Config state is DFU state download sync. So this is we actually need to do some kind of writing operation to the flash. Then how to make this work? We need to define a write call. It's going to need to take a reference to our buffer. Where to write the buffer to and how many bytes to write from the buffer. Data, we'll call that. That's a tricky one. I kind of actually need to define something in the build system to allow the specification of the page size of the device. Yeah, I can do that. It's just going to be a little bit icky to do because I'm going to end up with like macros in here, and I'll do that in a second. So we've got a write, flash state, write address for flash state byte count buffer. And then flash state dot write address plus equals that. Reset the byte count to 0 because we've now written everything we need to for the page. We then idle this state machine. Flash op rather, not flash state, whoops. We want to say that we're now in the download idle state. I know what I've done wrong here. Okay, so if flash state byte count is 0, we do one thing, otherwise we do the write and byte count cycle. Just realizing I actually need, there's a bit of time between things that needs to happen here. So idle the state. flash state, not flash state, config state, DFU state, download idle. What else do I need to do? I will need in one of these, I'm not sure which one, I'm going to need to make sure that we are doing a write that is in bounds. Which looks like it might actually need to be done in here. Which makes sense, honestly. So, in the case that... in the case that flash state erase address plus the packet length field would exceed the end address, we respond with a stall. Ooh, nice. That's cool. Good job, Aki. So if the erase address would be greater than the erase address plus packet length would be greater than the end address, we tell the computer, nah, sorry, not gonna let you write that. Otherwise, that's wrong. That needs to be the packet length. So we pull data. Which will spin, waiting for that data to actually come in. Ah, that's a point. I'm just thinking about how this works and thinking there's actually a subtle bug in here that we do need to look at. Especially as this would actually happen asynchronously. Actually, no, never mind. I can do what I'm doing. It will be fine. It's just going to be a little weird for the host to deal with. Yeah, so we've got callback done. We wait for the end of the zero length packet. But in the meantime, we can set erase going. I have to somehow make a way for the DFU driver to find out if the flash is busy. So we'll write a little function signature for that. Because what we can then do is, instead of this being in here, we want this to be here. Yes, here. So we get the packet coming in. We check that it's valid to erase the pages for it. We erase the pages, which is asynchronous. We then prepare a buffer for the data coming in. We wait for it to download to us, and then we set up for a done state. Actually helps to put that into write mode, into erase mode. Let's see. Done puts us in download sync. So if we've completed the erase, we'll do this. Because of how this is written, that should be impossible for us to stall on. So let's put this all on one line. Like so. Yeah, that's a hell of a piece of code. Guess we just need to actually implement the flash routines now, which this should... Okay, I need to fix that build system issue before I can go further. So let us do poke in here. Option DFU flash page size. Type is an integer. Min will be 0, max will be 8K. God help you if you've got a device that's got that big of a flash page size, but okay. Having changed that, we can then do if DFU in get option drivers build defs is going to include USB DFU flash page size as format, get option DFU flash page size. That should do the trick there. And then we can then use this macro, so we've got const express static size t flash page size is USB DFU flash page size, which is now a globally defined thing. We will also need to set that in here just so we have it need a T/C datasheet. How big is the flash page size on this thing? One kilobyte in cubibyte independently erasable blocks. Okay, so this is 1024. Okay, much better. So that stuff's whatever. I don't really care about those warnings right now. The warning I'm getting out of the DFU driver This is almost all span driven errors now. Yeah, okay. Good enough that I'm going to version control this. Let us do this properly. Build system first. Introduced a configuration option for the DFU driver to set the flash size. I don't need that using anymore because we are not using that in this code. Fixed. Oh, not fixed. Changed. All USB DFU uses of ubiquity to stood ubiquity and included a byte count field in the flash state structure. We then have all the stuff to do with our external interface that needs implementing by the firmware. Actually, yeah, let's just do that as one commit. Added a series of functions that must be implemented by firmware to let the DFU driver erase and write flash. Implemented the body of the download DFU request and the soft idle tick state machine required for this to work. Okey-dokey. Take care then, Steffi. Thanks for watching. I'm going to abandon the whole idea of checking block position information. It's just not worth the complexities. So, this should mean we've got one change that I haven't yet committed, which I need to go back and revisit. It's to do with getting endpoint status information. Because one of the two core drivers is not implementing that yet, which is why I've not put it in repo. Let us oh. Let us go and find substrate span and figure out why this is angry at us, and also fix this conversion warning, because the conversion warning's just silly. So in our dependency tree we have substrate, span. Hey, thank you. So, I think for right now I'm going to patch out this assertion, because I need to think very carefully about how to make that run in constant val space in C++ 17 and newer, and if that's not possible, then falling back to some other kind of check, noting I can't throw an exception here because we've made the function no except. So possibly that means we should be returning the I don't know what I'd return in that instance. It kind of needs an exception to be throwable. Yeah, because without that, it compiles. And if we now go and look at line 32... So this is... This is int. Oh. No worries. Oh, excellent, thank you. I'm guessing that was on Discord. Which I completely forgot to actually announce my stream on. Good job, me. So, this is a secret project that we've been working on. As you can see, the pretty light pipes. That's nice. I like it. And oh yeah. Oh yeah, that's great. Wait, did you make an antenna symbol? You did. That's awesome. Yeah, so this, the way it's implemented. Ah, okay. The way that this is implemented, though, means that each of those characters takes just 2 bytes to represent. Which, when you consider that this is a glyph font, this is rendered by the device, not the screen. This is cool. Yeah, I am stoked for this. This is just, oh, so good. Yup. That is 1/3 of the Flash versus just the bitmaps for the glyphs, by the way. So the comparison we're making here is that this way of doing font rendering that Erston has figured out is normally, for all the bitmap data required for this, for all of the glyph data, that is one amount of Flash. I think you said it was something like 9 kilobytes, or somewhere around there, 8 to 9 kilobytes. This, including the render code, because the other one did not include render code, that was just the glyph data, uses 1/3 of that. No more than 3 kilobytes. Which is kind of amazing. Just get a bigger Flash. Well, you know, we wanted to. Why is that even defined and how is it used? Because it's a forward declaration. Yeah, the external Flash is for the other function of the thing. Well, okay, that one change from a std pointer diff tn to a size tn does fix that warning. Ah, the teasing's good. Yeah, size t there rather is only appearing once. Whatever. Let us actually fix that in real substrate now we know how. So this was in span. So that's that first warning. And then the other one is this. What I can probably do is do if CPP, C++ greater than or equals to the definition for C++ 17, and if const expr std const if there's a way to ask the compiler if you're in a constant context. Stud is constant evaluated, and that's actually a C++20 thing. There is another one. If context for stud is constant evaluated, do that. And if I just gate that against being more than C++17, maybe that's okay. If I quickly do a little version control on the substrate repo, fixed a signed unsigned conversion warning in the span helper size and fixed an error about invoking a static assert in a non-const expert context. Sorry, very meanie me, I know, I'm doing stuff off screen. What I should now be able to do is depth substrate git pull git stash drop, because the only change I made doesn't need to be capped. Oh, balls. I will show you. Just a moment though. It's gonna want me to add substrate span there we go. Gosh, there is so few errors and warnings. That's nice. So auto stash. Oh, it's just my command line. Why not? So in my git config globally, as part of rebase, I have auto stash true, and as part of pull requests, so when I do git pull, it defaults to a rebase. So this is kind of like one follows the other. If I do a git pull, it's silently a rebase. If I'm doing a rebase, it silently auto stashes. Voila. It's a very nice thing to be able to do. So if we now do a pull of Dragon USB and of substrate, welcome back, Iris. We should get some... Oh, we should have got some link errors. We didn't. Oh, because I didn't push. Whoops. There we go, now we get the link errors I'm expecting. So, to fix those link errors, we actually need to implement the FlashBusy write and erase so dragonBoot is using Dragon USB as a wrap-based sub-module. I am working on Dragon USB outside of the dragonBoot clone, so I have to push Dragon USB to pull on the clone on dragonBoot to then do a build of dragonBoot. So I'm pushing to pull in a very fun way. Yeah, so I'm doing... You see, this is dragonBoot, cd-daps Dragon USB, pull. Having done here a push. my bad. Yes, I am fast on the keyboard. So, you don't want to even start to ask me that question, because it's to do with how my memory works. And for me, what works with, in quotes, too many tabs is actually really good for me. Whereas for someone else, I understand that that's just too many tabs. If we're going to talk about browsers, have some tabs. You can't see that. Have some tabs. I apologize to all of those who find that hard to deal with. I am far off the right-hand end of that tab bar. I will eventually close them, but it's just my brain and how it works. So I have multiple terminal windows open with multiple terminal tabs open. This is my hardware dev terminal set. So for example, I've got various stuff to do with PCB design, and then this one happens to be showing me my D message, but it's actually part of SPIFlashProgrammer. Then we've got the SPIFlashProgrammer build, MX keyboard stuff, Dragon USB, dragonBoot, etc. Going all the way along. Hmm. So yeah, I kind of have method in my madness, and I've got like other ones for dev of LibAudio, other ones for dev of LibImage, other ones for dev of Crunch, PCAT, Tempelorm, Arson, and Apon. That happens to be one that's just all of those together. I've got one for Viper, I've got one for Artis, and so many VS Code windows open as well. If I actually quickly go over here, you can see I have a gaggle of VS Code windows. The thing is that my consoles don't just have where I was last working on that particular console. The scroll back gives me context. They're all different projects, yes. And they're all in very specific states, so that if I feel like going back to a given project, I just have to get the console and the VS Code window up, and I know where I was at. Like, I can just drop straight back into the project and just be working. Right, I need to actually open the DFU header. So I can copy these. And de-extern them because they do not need to have extern again. The parameters need to be consted because I'm not going to be editing them. Okay, so I've just spotted a nice clang tidy warning. It's a fair game. I should have namespace USB DFU on the ends there, which I'll commit later. Because I care more about how does flash memory work here. So we've got interrupts flash memory programming. We've got the flash memory address, flash memory data, and flash memory control registers. So erase is going to need to tell flash control mem address is address. I know that one. I have to program a 32-bit word at a time. Oh my jeebus, that's gonna suck. The erasing a 1 kilobyte page, we write the address register, flash control is vowels. Yeah, for once I actually want to be doing that. Putting on the value key in the boot flag boot configuration register the value. Okay, so how does that depend on... So I'll have a key and an arrays thing. So I've got a set standard for this set of projects that is anything in the vals namespace are platform header values from this header. The inner namespace is then what peripheral the values are for. And then we have the prefix here of the register that the value is for, and then what thing it's doing. So that's how I'm able to generate those so easily. Flash control itself is in the T4C namespace as flash control T. It's a structure that we got from the what's his name? Aw. I'm sorry. Getting no drop frames from my end, so... So here we've got, like, all of the system control registers, and these are gleaned off of the... Oh, what's his name? There's a... SVD. SVD is what I'm trying to think of. Then I renamed some stuff so that it wasn't so horribly named, because TI have a habit of naming things in the most few characters possible, incomprehensible way. It's like, no, there are no character limits here, just give them their real names. Which is exactly what I've done here with, like, the flash control stuff. I mean, yeah, TI is a vendor. Hence, like, FMD, FMA, FMC, like, what did those mean? So, flash busy is true if flash control, flash mem control, or vals, flash control, oh, not or, and yeah, that's fair. So this chip is the successor to the Stellaris stuff, using a actually standardized core, etc. And granted, many of the same peripherals, you can take the Stellaris code and mostly build and run it on this. But there are some changes, like there are more peripherals, for example. This was the direct upgrade off of the Stellaris cores, T4C series. Fair comment. So the only grumble I have is that while the vendor header is actually not bad to work with, like you can get writing code with it really fast, the way it is licensed is impossible to work with. Yes, please go and make food. I need to have a look at that. I know it looked really good. Like, you were doing some great stuff with that. I just never, I think, got to looking at it. I will do. Because, yes, nice headers are a thing that I wish that this chip had. It consumes SVD files and it spits out headers for those SVDs. But not C-like headers, actual C++ headers. Which are, different. Yeah, I'm gonna have to give that a proper look over, because as people might remember, I had a hell of a time actually making this platform header, which that was a whole thing. They're good, but some vendors are very bad about writing good SVD files. They're basically descriptions of the internals of a chip, where everything is on the memory buses, what bits do what of what registers, what the registers are named, where they're memory mapped. The works. The only problem with them is that they are written as XML. Okay, so this is a 4-byte aligned address, therefore those bottom 2 bits should probably never be used. Flash memory data, that's the data to be written. What is it with this depending on the value of boot CFG? How does this depend on the value? Tell me what I should do. TI, seriously? Well, let's put the constants over here, and let's write constants real quick. So flash control comes above system control. And we are dealing exclusively with this register for right now. Flash memory or flash mem? Flash mem. So there's the 3 what to do bits, and then we have key. Oh, hey. Thanks for the follow, St. J. Graves. Welcome to the stream. And yeah. Oh, so boot CFG here. This doesn't tell me what... Ah! So if key is 1 here, this is key select, which is the default. God, this is awful. Then this is A442. Which, let's just assume that's always true. I will make mention of 71D50000U. Have I got it? Yeah, that's the right number of zeros. Is used when boot CFG key equals 0. We then have the raw interrupt stuff, which we don't really care about. I'm not using flash interrupts. Good girl. I'm glad to hear that, Aki. Means she's cooking food. Which is good. Yeah. This bit is used to start a buffered write to flash memory. Is there like a series of registers? Oh, you can queue up a whole load. I'm glad to hear that, Aki. Apparently there are 32 registers, 4 bytes each, so let's see how many bytes is that total. $128 bytes worth of registers, which can be used to queue data up to the flash to be written. I wonder how that's been done in the platform header. Has it been done in the platform header? There's the protection registers. User registers, boot configuration, ROM and software map control. Ah, sounds good to me. Flash write buffer N. That's this thing. Yeah, I should have, this needs to go down by 31. So this is 31. And this needs to be a stud array. (32), which is the flash write buffer. Only FWB N registers that have been updated since the preceding buffered flash memory write operation are written into flash memory, so it is not necessary to write the entire bank of registers in order to write 1 or 2 words. So we want bytes that are not present in the input data stream to be F by default. As in 255, FF, not single F. This is a map of bytes that have been written to, 32-bit values that have been written to. So flash memory control 2 we do need to deal with because we need the same key and write stuff. It uses exactly the same constants. Okay, I don't need to duplicate that. I just need to remember that for some of these I want to do flash mem control 2 instead of flash mem control. So how does that look in the DFU driver? Not DFU, sorry, platform. That means we check for flash mem control, erase cycle running. And we check for flash control, flash mem control 2. Yeah, so for write down here, we'll use this method because this is going to be far more efficient for our page size being a whole 1024 bytes. So we've got 32 registers, 4 bytes each, 1024 bytes input, meaning 8 cycles versus, well, 256 cycles, so it's going to be considerably more efficient to use buffered writes here to do the writing of the data. Ludaki. So this will do a loop from the start of the buffer to the indicated end of the buffer. We'll need to include substrate in this little lot. I can fix that actually if I define flash page size. I think that's not currently defined. Yeah, that's not currently defined. I've just managed to screw that up twice. Mise on private, CMD line. Neither of those two, thank you. Dragon USB, there we go. Now it's set correctly. I need to tell the builds, I need to tell IntelliSense about that because it doesn't currently know. That's why I'm getting the squigglies. Don't we all? Pull that flash data so it doesn't overlap with the existing variable. That builds. That's actually not terrible. So byte in da. So we're going to need to know where we are in the sub-byte group. God, I should really do this the more efficient way. I'm resisting doing this, but what I should really do is just do count divided by 4. That gets rid of this. We then do a stirred mem copy. Const auto offset is I multiplied by 4. We are copying into flash data data offset. Actually, data plus offset. My naming here was awful. That's better. So the amount to copy is going to be the stdmin of that versus 4. I think if I remember, it's like if you add 3 because it's less than the total number, if you're on the boundary condition, that pushes it up 1, and if we put that inside the loop, then that will get reinitialized every time. Then we can then do page offset? No, buffer offset is going to be our I masked with 31 because there are 32 registers. That's a number between 0 and 31. We then want to do flash control, flash memory, flash mem buff. Wow, what is that named? Flash write buffer. Why is it called that? I'm gonna rename that because, geez, that should really be flash mem buffer valid and flash mem buffer. Just for sanity's sake of naming. So we do a write to buffer offset of data if buffer offset is 31 then we want to do the honors setting the write in progress and waiting on its completion. So it's this key and vowels flash control write and then while flash busy continue. And whatever happens, we will now have to do a right at the end. Assuming count is non-zero, but if count is 0, then we should probably return early anyway. Because that's not really a valid thing to do. I'm gonna have to tell the friggin' DFU driver about the blasted buffer, aren't I? Which would also simplify this a huge amount, because then I wouldn't have this really weird, messed up loop. I'd set up the area of all of the data to be written with the last byte padded with this whole shenanigan I'm doing, and then what I'll do is, if amount is for you, then do one thing, else do the really bleh thing. Which is, that's the smart thing to do. Oh, because it's a volatile... Never mind, there is no smart way to do this. I have to do it this way. Because of the fact that I'm dealing with a volatile. Volatile pointers can't be passed to functions expecting non-volatile pointers. It is an error to try. I mean, it's not at least it's not a terrible amount more code, but the problem I've currently got, and the thing I'm spluttering about, is the fact that this is going to tie up the starter frame routine for goodness knows how long, and that's not how this was intended to work. This was intended to work asynchronously, which is why the DFU driver in Sylvian's code was doing so much offload from this. This was taking that sub-page amount at a time and doing stuff with that. Now, do I actually need to pass a count to arrays here? I do not need to pass a count. So, okay, we've got some slight refactoring to do. That will improve code size as well. So arrays does not need to take this count. The DFU driver... needs to deal with the sub-block stuff. So this is going to be flash buffer size. So this is describing how big the device flash write buffer is. Well, actually, how big the flash write buffer is on the device. That's slightly better English. And then instead of passing the whole stud array, we pass a pointer to the buffer start that we have for the subwrite. Alright, because extraneous const, yay! So that means we get to do the whole offsets within the DFU block. So we'll need to deal with the whole offset and byte count. Otherwise, we want to have amount is the stud min of flash state byte count minus flash state offset versus the flash buffer size. That line's probably a little confused on its types. Oh no. So we have write address, amount, buffer.data plus offset, flash state offset. And then flash state offset gets the amount written added to it. As does the write address. Yeah, that's better. So the way that this will then work is that every time a tick happens, we try and write another buffer amount of data, which does mean it could be a little on the slow side, but we do get called once every millisecond or something ridiculous. Yeah, this shouldn't be that bad actually. And we're doing almost as large an amount of writes per go as the other driver does, which I know it runs pretty quickly. Let's try building this. Let's set the flash buffer size properly. And this was 1028. Okay, so that builds. Added an option for specifying the DFU flash write buffer size. We then have fixed the implementation of USB DFU tick, USB DFU write, so the flash write is async, because that is essentially what we are trying to make happen here, and fixed the API of USB DFU erase. If we pull that, first build's going to be broken, that's whatever. Because we need to do flash buffer size 128, and we now have to go and fix the driver. So the first bit, erase is fine, count const uint 8 keys star const buffer. That's the second part. If if not count, return. I need index sequence to be able to take a stride. Good go, Aki. Good go. So index sequence at the moment does not take a stride. It just takes an end or a beginning and an end. But it should really have some way of being able to say, instead of just plus plus when you want the next item in the sequence, it should have a way of saying, actually, add this amount, the stride, so that we get the full Python range support, because what I really want to do right now, but this does not work yet, is for const auto, this will be offset in substrate index sequence t 0 to count with a stride of 4. That's what I want to be able to do. But now I'm just gonna have to do a dumb for loop. Like that. Well, let's rename I there to offset. That gets rid of that. That means we need to shift that down by 2. That's effectively a divide by 4. Then we get the bits to get the buffer offset. Amount is count minus offset versus that. Data buffer plus offset amount. Buffer offsets that. And now we get rid of this because we can guarantee let's make sure that count is not more than flash really? None of those constants are showing through into here? Really? We're in the right namespace. Stupid thing. Try and find the right thing myself manually. That's what I was looking for. Flash buffer size. So if count here is more than flash buffer size, that's a big problem. That's something's gone very majorly wrong with the flow in this code. So we've written this on the assumption that that is never true. And now we have in our asynchronous flash write, which is perfect. What do I need to do at the end? So we've got program. Now the last program request. This is where things get complicated again, don't they? Let's check that that builds now. It builds. Okie dokie, take care of it. Also, if I actually make sure to set the address to write to. So we've now got how many warnings? We've got exactly 2 warnings from the device driver and 1 warning from the DFU driver now in dragonBoot. That's good. So get add p commit fixed spurious untidy warning firing. Commit fixed the PID. Actually, no, I can't do that yet. Because I haven't got the okay from KiCAD's people. So what I've just done here is fixed the way that must enter bootloader works, or actually introduced must enter bootloader. I fixed the naming of the descriptor. Which reminds me, I actually do need to further fix this now. We need to include the DFU driver. And use USB DFU flash page size. That is the name of a class. Or rather, not a class, namespace. Whatever. It builds, so that change is right. Fixed the DFU descriptor to use the correct max transfer size constant. Added a disasm target to the build system. We're getting there. implemented the firmware side of the USB DFU driver interface. Actually, I'm going to amend that because that message is not quite entirely true. For the TM4C123GH6 PM, because I've done that quite specifically for a platform, not for the general case. So as you can see, SRC, TM4C, platform CXX. So I've got different platform implementations depending on what microcontroller you choose to run dragonBoot on. Because of course we'll need to do something different for APR, which this is also intended to target at some point. So, there's exactly one way I get to find out if this all worked. I need to tell SPIFlashProgrammer to use the correct origin and link arguments. I think it's that. Let me go check the DragonTie build system real quick, because that's the easy way to find out if that was right or wrong. Compile args, include args, link args. Yes, so I only want compile and include. Compile and include. Perfect. So what I've just done is I've switched myself off of using the DragonTie linker script to using our internal one again. Oh, ravioli. Tasty. That makes it so that this will build for further down in the chip memory. Ooh, very nice. So if I update the dependencies for SPIFlashProgrammer, and DragonTie as well, because I did change stuff there. Ooh, no. Right, I have a problem I now have to fix. I've made a whole pile of changes under dragonBoot here to DragonTie. That I now need to copy back to the upstream repo. The easiest way to do this is going to be copy constants and platform to the original upstream project. Nice. Added, register constants for the SBC, a pint, and flash control, flash mem control registers. plus fixed a couple of mistakes in the platform header. Git restore, those two git pull. Huh, nice. Okay, we still link and build correctly, so let us push dragonBoot. Pull dragon tie here. Rebuild. Okay, as expected, because I'm including the DFU driver, that does not build. But, as mentioned before, these can be stubs. Right. So let's quickly add stub stuff into SPIFlashProgrammer. Huh, nice. That's a very high honor from you, Aston, I think. Meant in a good way. How did I lay this code out, and where do I want to add this? I guess down here will be fine. So this takes a studio input to T. It does nothing. And then right is very similar. There we go, we now have stub functions written. Oh right, and I also need to define a reboot function. So this needs to no return, and this will be used by the firmware. So this is to get back into the bootloader. This is where we get to poke a point. Poke a point. So this is this. Yeah. God, Aki keeps making me nya. Or rather, making me want to nya. Nya. You're cute. Fine. Anyway, there we go. So we now have. Yeah. Yeah. There you go. Have some more nyaring. So we now have added into the program space there. We now have all the extra stuff required for the DFU driver. But compiler is being smart and realizing we're not using the or actually no, I left it unconfigured. Yeah, see these are 0, so that's why we're not spending memory on them. I think I'm fine with that actually. Are we getting any spurious warnings as a result? We are not. So if I put the bootloader on the device, and we do DFU util list, cannot open DFU device. Interesting. That's probably I'm missing some descriptors. So if I look using OpenVisla at what's happening, let me just unplug and replug. Interesting. Why is that sending a stall with data? Okay then. Apparently I'm managing to send a stall and data. That's gonna be a fun bug to try and figure out. Excellent. Oh, DFU util probably can't open the device because the udev rule for it does not exist. Okay, let me quickly open a console, then switch to root. And we'll go looking at etc udev rules. And we'll copy the Blackmagic rules as SPIFlashProgrammer rules. Usually done with hyphens. So the answer is SPIFP rules. SPIFP rules. I don't need to do anything with adding symlinks, but we do need to do ID vendor 1209 product IDs. Actually, these should probably be the bad alloc rules. There's one set of rules for all of the things that will do dragonBoot. We've got bad B and alloc in a very fun way. Yeah, that looks right. I guess as well I'm going to need to do a similar rule for bad A keyboard. So let's call this bad alloc rules. And then we do a udev control, sorry, udev ADM control reload. And the easiest way to re-trigger is going to just be unplug and replug the device. So let's restart USB so that we get a clean capture of what's happening. Yeah, I really need to fix whatever's happening with poor descriptive forward there. And there we go. So we are getting string. Why is that going unknown unknown? What is the Blackmagic probe doing that I'm not? As far as name, serial... That's weird. So if we find this is currently attached. Well, I don't know how to at the moment. Which USB descriptor? There are several, but I'm not seeing an access for that for the descriptor I'd expect. See, it's pulling back the language information, but it's then not pulling anything else back, according to the analyzer, unless there are some packets in flight that we're not seeing this way, which would be weird because this is literally looking at the USB lines. VUSB and the physical analyzer is a OpenVisla. I need to switch over to my Luna, but I actually need some extra USB cables for it, which are on back order. Yay! So OpenVisla is a FPGA-based capture device for the traffic. It sits inline on the cable, as in you plug the USB A end into Visla and it gives you a B port out to your host, along with a second B port, which is the one that this talks to, which gives you the traffic on the wire, all nicely reformatted, etc. And then this is a program... Yeah, I need to do Luna things too. Luna's pretty and just so this is a program originally written by Kate Temkin and KiCAD, which uses a whole pile of different backends to be able to then pull data about a USB device that you want to interrogate and look at the traffic on. Say because you've got a bug in something you're doing, like I do here with my whoopsie, I'm installing when I should install, and gives you a interface to that data with decode and a whole pile of nice stuff happening. So like, for example, you probably saw here subordinate descriptor decoding, and it's telling me exactly how the interface is configured, etc. Doing a full decode on the data that is being sent over the USB bus. And this is in a manner that is considerably nicer than you get with Wireshark. Because Wireshark is trying to be too general, so it's trying to shoehorn USB traffic into a networking-like system. I'll actually show what this looks like in Wireshark as a comparison, and you'll go, oh, I'm sure. So if I throw that out the way, and we run up Wireshark, oh, I actually have Wireshark up already. Yep. Yeah. So if I run Wireshark, and if we check, this is interface 5. And if I now just unplug and replug the device, and we try and do the DFU util bit again, this is all I get. So you can see here, for example, we've done the setting everything up, device qualifier, configuration descriptor, and then like, this is how it does the decode, and it's just, it works, kind of, as long as things are making their way far up enough the stack. But if we look further down, so you've got to set configuration, which is doing what it's doing. Get a descriptor. So this gets bootloader DFU configuration as a string descriptor. A request, response. And this one is empty, but it's not actually empty. This is just that the USB stack is filtering out the data that's just garbage. And then there's our get lang ID, which it doesn't know how to decode, which is hilarious because that's English. And again, try and get the bad string, and it just filters it out, which is completely useless for debugging what's going wrong. That's why USB. Because it is a significant upgrade over that. Now, for the right piece of code. This is that all looks fine. So yeah, device firmware upgrade interface should not be causing problems unless the logic for sending a larger than one packet thing is broken inside of core, which it could be. Or rather not core, device. Do reattach. There's the handle DFU request stuff. Oh, good God. The standard includes a table, or rather a listing of source written in the most C way possible, with underscored variables. You should not put underscores in your variables like that. That's undefined behavior. The compiler is allowed to do what it wants as a result of that. Come on. I mean, in this case, the undefined behavior in question was in C89, so... they had a few years to figure out that that was not how to write code. But it was probably Microsoft written code looking at how it was written. Because it stinks of Microsoft exemplar code from MSDN. Which is basically how not to write code, for what it's worth. So it tells me all about the requests. Yeah, well, good point. There's runtime DFU descriptor, but that's just telling you how to set up the interface descriptor, which I'm doing. That's this. And then have a functional descriptor. This is a DFU descriptor for the device, which that'll be 12 hexadecimal, which is 18 integer. 1 USB 2.0. Well, it wants a 1.0 device descriptor, but no, 2.0. That's fine. Class, subclass, protocol, packet size, vidpid, device version, who made it, what's the product name, serial number, how many configs, which in my case is 1. Then they're saying for an interface descriptor, so DFU mode configuration descriptor, that's fine. Interface descriptors, there's 1, the length is 9, the length is 9, interface is 4, interface number 0, I'm supposed to have more than one interface descriptor, and I'm supposed to return an interface descriptor per zone? I bet that's what that is. Though that doesn't tell me how I tell this what the zone information is. But that would explain why this was saying no, it doesn't explain why that's not working, actually. That should be fine. So, I was reticent to do this, but what I can do is I can repower Blackmagic Probe, having unplugged it from the other board. I can repower Blackmagic Probe into its bootloader mode. God, those LEDs are bright. And if I now look, around DFU, Blackmagic Probe is my debug interface that I've been using to debug this board. And also to program it. So I've just rebooted my programmer into its bootloader. But the important thing is, if we now do ls USB verbose device this, Yes, indeed. Probably because that is the name part of thing. Yeah. So yeah, we have to go and fix that in a moment then. What I was hoping to see here was the alt mode stuff, but we're only seeing the descriptor for alt mode 0. Ah, but this, the interface thing, is what's giving name up here. That's why it wants to get descriptor 4 back. That makes sense. Index a string descriptor for this interface. It doesn't say that that is used as the product name in DFU util. I think that's a DFU util specific thing. Path configuration. This number. Setting. Serial, transfer size, upload, download. How do I ask this for the available zones? It feels like I should be able to ask for the available zones, and I'm not being able to. Let me plug a device I know that's multi-zone in, having put my SPIFlashProgrammer, oh, my interface, my debug interface, back into its run mode for SPIFlashProgrammer. I'll have to unplug my phone temporarily, but that's fine. Yeah. I'm supposed to send back multiple interface descriptors that say how many alters there are. And each one represents a specific zone. Yeah, Alt 1, Alt 0. Okay. That's gonna make life, interesting. But we can make that work. What I'll do is, in descriptors here, in the USB descriptors namespace, we'll create a const USB interface descriptor T, DFU interface descriptor. I think, is that right? Because Actually, I guess that doesn't matter in our case because I've only got the one zone anyway at the moment. So this is just figuring out why string descriptor 4 is broken. So we got string descriptor 0, 1, 2, and 1, 2, 3, and 4 because they start at index 1. USB, DFU, bootloader. Actually, I'm going to change that from Dragon USB to dragonBoot DFU bootloader. It's slightly more descriptive of what this is. That's 25 characters now. That's fine. And I'm gonna have to look in Dragon USB here as to why it should be working the way it is. I'm gonna put my board I was just using to find out how the alters work away. Which is a really fun board, by the way. That's a Icebreaker Bitsy. I have to thank Eston for. So device CXX. Handle string descriptor request. Total length. So they're great. They're a really nice little FPGA board. Very, very handy. So let's do target extended remote. I'm going to skip this because I'm going to need to talk over it. Target extended remote dev TTY Blackmagic probe GDB patch. Load the new firmware. Put a breakpoint in on. Let me clean up a little tiny bit what I've got minimized and not minimized. Break on device CXX line 104 if descriptor index is 4. How do I find out information like this then, you silly thing? Because I can't turn optimizations off entirely, I don't think. Oh, string dot. Oh boy. Now I'm intrigued. She always brings me really interesting stuff, so I don't mind, but... What is that length to? Yeah, it's picking the last one of the group. Oh, I know why that's 2. Okay, so it's 2 plus hex 42 for hex 44, which is 68 bytes, which is of course more than the maximum transfer size of 64, so it'll get split over 2 packets, which should be fine. We then... That's why I couldn't find it before. Okay, so... Control there is saying... What? I need the USB types header. We got 1, 2, 4, 8 memory type. So control. Yeah. Oh, that's USB EP setting what endpoint and direction, which is kind of pointless to actually have in there thinking about it. So we can probably make that more efficient in a little bit. But so we got transfer count number for part number. So we've told this that part number's 0, parts data is non-zero, so it's now got the right where data is to be transferred from. Value of 8 is multi-part true, no stall. What's up, Iris? Oh. Responses to we've got data. am currently trying to debug why that string descriptor was being returned incorrectly. You remember how we were getting those stalls when we shouldn't have been getting stalls? That. I am literally stepping through code on the device, trying to figure out what the USB stack is trying to do and how it's trying to set the transfers up. Which probably is making my PC quite unhappy, but it's Linux, it'll deal with. So at the end of that, we have so far found that it's correctly saying that it's not transfer terminated, it needs arming, it is not stalled, and it is multi-part. That's what this A means, because that's hex 1010. And I can see through my console what those bits mean. We've set the memory buffer to null. We've set control is what it is. That's... yeah, I don't think that's even used anywhere, so I think I can remove it from the structure at some point. Transfer count is the next thing to be assigned. Good. Print... oh, sorry, list, not print. I was gonna do that. Interesting that that's only 58. That seems short. Based on the previous values I read out, which should have totaled... take care of it. Should have totaled to hex 44, which is 68. So this is a short transfer, but that shouldn't be the reason why this isn't working. Oh, transfer count is correct. Oh, I'm an instruction behind, or rather a line behind. That's why that was... that one. So, transfer count is correct. Part number 0, parts data this, so this is the multi-part transfer data, and we've set it up now, ready for a multi-part transfer. And if the response is data, and both the data member, i.e. what becomes mem buffer, and is multi-part are both false, i.e. it's a null pointer and there's no multi-part, we abort the transfer, but that shouldn't happen here, and it doesn't. That would have changed needs arming to false. And instead we go into complete setup packet, which... oh right, that's in the target specific part of the device driver, because I haven't yet managed to get that all merged together. Because of this. Oh no, that is in the generic part. Why? Ah, there it is. So we check if we need arming. So that's gone. It doesn't need arming. And the type is... controller in. No. Okay, controller in is, yeah. So it's gonna go and put us into data TX mode. Which, the end of that is if there's still transfer left to go or not. So we then go into write EP. Oh, what a terrifying routine this one is. Sure, we'll step into it. So the send count is the max for the buff for the endpoint, so we've got 4 bytes trailing. Four bytes trailing. We are a multi-byte transfer. This bit gets held quickly. So set up some buffers, endpoint status. If we've got no current descriptor data to maneuver, grab the first part. Okay, so while we have data to move, we grab the first part. Yeah. Okie dokie. Sleep well, Aki. I should probably try and finish up soon, but I really want to debug this, because, well, this is annoying me now. Because this is well-trodden code, because this is how the descriptors are sent and received. Not so much received, but sent. So we've done setup. This is true, this is true. That gets optimized out, apparently. Okay, so that's down 2 bytes? 2 bytes. There is no leftover count right now. But there will be a remainder of 2. Send data should... end up doing nothing. Yeah. The USB engine probably doesn't much like me doing that. A, B, C. Yeah, it's moved us along 2 bytes, which it probably didn't very much like. But that works for the other string descriptors, so... Oh, no. Okay, I know what I've done here. Yeah, that's an adjustment I made so that the code would flow better. It didn't write anything out yet. This is now going to do the fix-up step. Yeah, okay, so we've got string descriptor front there, D03, the D, if I translated it, will be the total size of the descriptor. So do more setup. We'll have sent everything at the end. We then do the... we have leftovers. So we fill the rest of the leftover buffer up and send it. Which we did. And then... C, yeah, okay, that's the rest of the buffer. And there's no fix-up required because that's an exact amount. So we don't do anything there because we're still in a multi-part transfer. That's fine. Computer's well past caring at that point. So yeah, the multi-part transfer for the first part is actually being set up correctly. Assuming... I mean, that was to endpoint 0. Pretty sure that was all for endpoint 0. Endpoint is 0. Yeah, right, EP endpoint 0. So yeah, that was all correct. Should have meant we got that happen. Because we weren't yet done with the data phase. So if I just reboot the thing again. Invalidated 2 sub-packets, then we get a stall. I'm tempted to get a slightly more raw packet capture of what's happening. Because we're getting the first part of... Yeah, we're getting the first part of the transfer happen just fine. And then it stalls. And I don't know why. Yeah, weird. Let's finish doing a dry run here of what's going on. So we go... This is going to return false. So we drop out here, complete setup packet. We drop out of handle setup packet, back into the main event loop handling, because handle control packet, handle setup packet, yeah, that just returns. In the next iteration through, we get an in token, so we go handle control in packet. I didn't check if setup callback is non-zero, so it shouldn't have value. Then we do, if we're in state data tx, which is the state we should be in, and we write data out, and we're done, we go idle. Otherwise, this was because we just finished. The only thing I can think of here is that pullback is non-zero. The easiest way to find out is going to be by breaking in that function where packet.request is getString. That's a USB types request, yes. One extra byte each time. Cool. That didn't work. Well, it kind of worked, I guess. I can just quickly do the whole... what's it afterwards? It's NVIC table, okay. I mean, the device is now clearly screwed, because it's gone, I can't take an address, so, yeah. I broke it, but in a really fun way, because I'm running it in a debugger. I just made my analyzer really unhappy with me. It overflowed its buffers. There. Ah. Hooey. I don't know why that didn't trigger properly. Because it's not like that was out of scope. That's like the whole point, is that packet is very in scope here. I'm trying to remember. I think in the case of a setup packet, we'll have gone status TX. So we probably want to move this down, actually, anyway. On the condition that we've gone to state idle. Which, I mean, gets rid of half the problems that are potential in that anyway, so... Improved the setup callback, USB device setup callback, support. What is the weird part here is that it's going and stalling. I don't get that. There are exactly 2 places where we can stall. And one of them only happens if the device thinks it needs to do another read. And there is no data to read. Which, because of how... Well, no, because of how, oh, which bit of this was it again? Here. Because of how this is set up, that can only happen if it thinks that it's a controller out packet, which this is an in transaction token I'm getting. Controller in happens. So that would indicate a bug in core, which, why has it taken this long to express it, and why is it so consistent in this, where we've got RX status or endpoint 0 and status control L RX ready. Oh, please don't. See, what I'm seeing in the decode here is we get our first 64 bytes, nice and handy, and we see device firmware upgrade interface, but with the last letters truncated off, which is exactly how I would expect it to be because I've not yet moved them over the interface. It knows it then needs to ask for a few more bytes, which it does. As an in token, The stall is the bad part. We shouldn't be stalling. We get an in token and then we stall. Okay, what I'm gonna do, because this is not telling me what I need to know. That's a side effect of the stall. I'm gonna manually run OpenVisla. I mean, it's a pain in the ass to read the data from, but it works. So, what we're seeing... This is the get string descriptor for that's string 1? Yeah, that's string 1. 3 4. We get our ACK data. Which is yeah, so this is the string descriptor start. These are the string bytes checksum, or rather CRC. ACK install setup. Blech, which, because of the stall, gets redone. But yeah, it's just straight up just doing stall. We're not seeing the other part of the data that should be being sent. Well, that's doing right on EP0 like it should be. It's doing a read on EP0 like it should be. Right, EP0 is multiplot should still be true. I know how I'm gonna get the breakpoint I want. I've just figured out how I'm gonna do the breakpoint I've been needing to do to figure out what's going wrong. Oops. Not quite what I wanted to do. So, ultimately this comes down to where we're going through device here. Now, if I put a breakpoint in... Yeah, if I put a breakpoint into device CXX line 343, if, and then we check the USB state part of things, is not state addressing, which we'll put a proper qualifier on, because otherwise GDB won't find the type. Oh, must be for internal. And I'm also going to run the Qt version of the GUI for... Oh, I can't. Interesting. Oh, is this the whole... Vizsla changed the way its UIs work, so now I can't use one of the UIs. Sad. Okay, so this is trying to get descriptor 4. Which is already stalled by the time we get here. Oh, interesting. It knows it's got more data. What is causing a stall? Why? Why are we stalling? Print USB control. I shouldn't have done quite that, because I just accidentally read data out the FIFOs. All of them. What I should have done is checked EP0 control. I think it was. No, not control. Oh yeah, that was right. Status control L. 1515. This is where this thing running its own state machine internally becomes a problem. I really need to know what this register does and means. Here we go. So we're in device mode, so... This means RX ready, stalled, and setup end are all set. Where was that break I put that gave us the nice innards of how the string is being transferred? Because that worked. So, having done all of that, we've set the transfer up, etc. If I now look at USB control, EP0 control, 1.7. That's set and stalled TXRDY, RXRDY. Why are you stalling? What is possessing something to write to bit, the stall bit, which is hex 20? I'm gonna put a breakpoint in here. With the same premise. .4CXX line 359. Well, it happens sometimes, yes. Oh. Bloody fuck. Packet. USB device packet. It'll be value. Already can't use as descriptor, but the conversion to a Uint16T should work. And we're on a little Indian platform. So I want for type here to be three. Request type request. Oh no, 0303. This is going to be 0304. Yeah, 0304. Because little engine, so things backwards. I love that. Nice. That value does not match the one I'm looking for. It was watch, wasn't it? The USB driver just got really pissed off at me. Reasonably enough, because I was stalling like crazy. Thank you. Nice. Thought it would be in your best interests too. Wink wink. That's understandable that you wouldn't want to do that. That would be interesting. Let's try that again, because I managed to completely break things there. That was interesting. And I didn't want watch points, I wanted a... Let's not show, display, that's what I'm looking for. And as we can see, device USB device packet value is the value that we're looking to break on. I didn't mean to set a second breakpoint. Info break. There's one breakpoint. And if we now run, which is supposedly now doing its thing again, where it's going to enumerate yada yada yada. It's not enumerating. this is the point where I'm at, where trying to inspect what's broken breaks it further. That's really frustrating. As soon as I stop looking, it just does it. Well, except for the fact that it's still stalling when it shouldn't. Huh. You say that, and yet you're probably not wrong. Good question. Gateware would be the general term, IP as if it's somebody else's property. Nice. Hmm. That's correct for 8. Transmit ready. Transmit ready. So I'm gonna see what happens if we explicitly clear the stall bits. Does that improve things? Which of course I'm gonna need to copy into the current build. DragonBoot, steps, sources, core, not that core, that core. Helps if I am using the right variable. If I restart Vizsla again, rather USB. Okay, that didn't improve anything. That's still stalling. So never mind about that change. That's wrong anyway, so let's get rid of that. So DragonBoot got unmodified this. Let's actually have a look inside the device driver here. The thing I want to do... I think that's technically in the wrong spot anyway, but that shouldn't be hurting things. Famous last words and all of that. Oh, are we in the USB core stuff? Ice mode. This is if setup end has happened before last data, then we that feels like it belongs in here. I'll this. So we've got no low luck yet. Should have a receive ready. Rather, no, we shouldn't have a receive ready. I'm gonna just look up and see if I can find all the places that stall stuff is used and done. Also, that's interesting. Oh, yeah, okay. That was actually correct. Let's use this one instead then. So at no point am I ever clearing stall condition if I'm setting stall up. Oh, is that biting my ass? So if we do if no, so the datasheet makes it really clear. This is the USB control low 0, and it says a stall handshake has been transmitted. Software must clear this bit. So this is only ever happens when you set stall. So if USB control EP0 control status control low and vals USB stalled, let us clear it. And this will need to be made into a uint80 because tilde undoes stuff. That's done for atomicity. Yeah, so there are some things in this controller that need to be done atomically. And it's a cheap way of getting that without having to go to full barrier instructions and that kind of thing. That didn't fix it. Rumbles. I mean, technically now I'm being better behaved, but that didn't actually fix it. This bit is automatically cleared after stall handshake is transmitted. Oh, that's what I thought. It doesn't appear so. The request type direction should be controller in. We go into data tx state. This returns false, so we don't touch the USB control data state. So I should probably check that. See if I can set a breakpoint in there. So the breakpoint I want... I shouldn't be. That's the problem. Something is causing my firmware to set the stall bit, or the state machine to do so, when it shouldn't be. I can't. This, for example, must happen, or I will cause problems and we will not enumerate. If that makes some sense. Yeah. A stall is in EP0, a stall at that particular location is I don't support the request you requested of me. And you must be able to communicate that. I'm gonna first check if this line here in complete setup packet, if this is doing the right thing or not. So this is line 248. If that. Why did I hit continue? It was supposed to be run. Reboot the device. What is it with, if I set a breakpoint like that, it just does not work? Let's try 255, because I know 255 is not being optimized out. That would be interesting. It's usually pretty robust nowadays. I did, however, just go and crash my analyzer. That was fun. Yes, actually that did help quite a bit. It's almost like when you say, oh, let's stop being idiots inside the kernel and make the interface sane, good things happen. I'm just trying to think about how on earth I can cause this to break properly where I want it to. And the only thing I can think to do is put the breakpoint back in here and then do lots of stepping, which is shite. So let's break on device 108. If... I don't know if Blackmagic Probe works with those. But that could be interesting. I'll see if that works in a moment. Okay. Because what I'm going to do right now is just going to do if the scriptor index is 4. Really? Oh, probably because it just goes out of scope on that line. Yep, because it goes out of scope on that line. That ain't gonna work. I'm gonna just restart Blackmagic Probe real quick. By which I mean yank the power cable on it. Now, as soon as I try setting a breakpoint like that, it just does not want to do so. That is so... shite. So, okay, yeah, let's do what Iris is suggesting. So... the condition for that breakpoint is if packet.value.value is 0304 U. It's BRK, isn't it? Oh, just back at the value, because I'm... bad instruction BRK. I can go and pull the reference off Aki's pool. One moment. Not other... sorry, documents, crawler, ARM, and we are looking for the ARM Cortex M4 TRM. Oh, literally, I mount her pool across the internet through SSH, and she mounts mine. It's great. Very useful, too. As you can see, I've had this open before. ZFS pool. And it's an SSHFS mount, so... slightly cheaty, I guess. But... move, multiply logical, loads, stores, semaphore, branches. Ah! PK, PT, 0. That should be breakpoint 0. Probably. Ah, it builds. Why is Blackmagic Probe trying to run this in this way? Let's just, again, completely restart the MP. Full stack. No power on anything. Let's try that again. It's not working specifically because... ooh, hello, Hardfault. It was specifically not working because, the device was running, how do I go into the Hardfault handler? Because Blackmagic Probe was running the device in an emulated mode, basically. I think. I'm doing something a little weird. If we set a breakpoint, a traditional normal breakpoint, in yes, because I accidentally hit enter too soon. After I had an alt-tab error. 104. Okay, we hit a breakpoint. Sig trap. And I already saw that it did a stall. So even at this phase, it's already armed for a stall. Ow. Print USB control EP0 control. Yep. Already toast. How annoying. Thing that's important though. The trick did work. We've got a breakpoint. But at this point it's already done a stall. For some godforsaken reason. So I think something is wrong in write EP 0. Which puts us back in core, where I don't want to be. So if USB device packet request is request T get descriptor and USB device packet what index? Which one is it? It's value equals 0304. Stick a breakpoint in. Okay, we have our breakpoint. One. Okay, why are we at 1-1? That's receive ready. Set end. Oh, that's so cursed. Because the kernel can't do shit about that. Nor about half a dozen other things in the whole stack. Well, yes, I can see that, because program receives signal stick trap. Trace breakpoint trap. But more importantly, if you've got a debugger attached, you just stop and go straight into the debugger. You don't even get the sick trap at that point, I don't think. Or you might get the sick trap, but the debugger will handle it for you. Yeah. And I think if sick trap is unhandled... Yeah, but I think if sick trap is unhandled, am I right in saying that the default handler just ignores it, so you just continue? Oh, okay. I would be surprised if that's an abort by default. Because it's not like SIG FPE. Anyway. So, transfer count is 4. And the USB control state is in core, right? Core internal. Data TX. So yeah, we would do a normal send. There's no stall. No, stall is not being set there. What I can do is I can set stall up here for a little break pointy. It's possible. I think what's more likely is a spurious call to stall EP. And I just need to filter out one get descriptor. So if get descriptor on... (0600), that's the device qualifier descriptor, does not match. So if not equals to that, or not that, breakpoint. If we stall for any reason other than the one thing I should stall on, break. That's what that'll do. We don't get spurious call, so you're right, this is hardware. For some reason, this is hardware. Yeah, this is bad. This is very bad that the hardware is causing EP0 stalls. That's sad time. Can the hardware set stall? Why can the hardware set stall? I didn't think the hardware could stall things for me. No, there's no time mats involved here. And it's not even like it's retrying or anything, it's just hard hitting stall. Just goes, nope. And configuration, point configuration. Well, who would they be? Didn't know I had vendor support. Oh, and I've also just realised that DFU stuff would never have worked because I'm never enabling starter frame in core. Oops. Well, I can fix that easily enough. So in here, when we go through reset, do a cycle bus. Oh no, we are enabling starter frame. Never mind. Okay, so that's fine. Yeah, we are doing starter frame handling. So the tick stuff will work once everything's all plugged together properly. I thought I'd remembered about another potential bug that had left in the stack, but nope. I think I'm going to finish up shortly. I'm going to see if we can figure out why stalling can happen. Stalled control transfer. The USB controller automatically responds to certain conditions on the USB bus or actions by the host controller. The host sends more data during an out phase of a control transfer than was specified in the device request during the setup phase. Okay, that first one doesn't apply. The host requests more data during an in phase of a control transfer than was specified in the device request during the setup phase. This is detected by the USB controller when the host sends an in token after TXRDY and data end have cleared. What I'm gonna try, what I can try is because we've got two buffers, we got double buffering, so I can try one quick thing. This will be in device, wrong device, that device. Where complete setup packet, if write EP0 or write EP busy 0 and write EP0, what that will do is it will queue both of the two transfers, one after the other immediately. Let's see if that works any better. The answer is no. No, it does not work any better. It doesn't break anything, which is nice, but we are still getting slammed with an automatic stall. What I just did is I attempted to leverage the double buffering. So if complete setup packet can't write all the data in one shot and the endpoint is not busy after that first shot, try the write again. That should load the other half of the data to be sent. Double buffer. But that doesn't work. I mean, it's not broken anything that I can discern, but it's also not fixed it. So that should be false. That turns this into true. causing us to call right EP again. Yeah, I should be firing a right EP, the buffer goes out to the USB core, firing it again very quickly, and then we go idle. Requesting 255 bytes, the string descriptor doesn't know how long the string descriptor is. Okay, yeah. I've been streaming for 7 hours. I should go to sleep, because I've got stuff to do tomorrow with Aki, and I am frustrated at this. We've got a good amount done. We did actually get the DFU core functionality written, even if we haven't been able to test it yet, because this is broken. But it's been good, generally. Thank you all for watching. I will see you on my normal Saturday stream next week. Where, if I've managed to get this working... Yeah, I know. If I've managed to get this working by then, I should be able to say, yay, we're doing DFU now. In which case we'll do DFU on the keyboard. Because I've got 2 DFU cores to... DFU drivers to work on here. If this is still broken, then I might well do another stream on this. But if I'm really hoping I get DFU working partway through the week, and I can then say, okay, let's work on the keyboard. In which case I will then be able to get onto profiles, finally, again. And we're actually quite close to closing both of these projects out, which is great, because I really want to get onto some new stuff, particularly hardware. So, thank you all for watching, have a good rest of your day, and I will see you next time. Bye for now.